So hello guys, my name is Amit. So today we are going to discuss this question, help Smith family. So question goes something like this that um, Smith family is invited to a birthday party and unfortunately all the family members, there are four family members, Anton, Bert, Doris and Klaus could not agree to go together and these are the following conditions that at least one family member goes to the party. Um, A cannot, A does not go with D, that is, Anton doesn't go with Doris. B will not go with C, that is, Berta will not go with Klaus. If A and C goes, B will not go, and if A does not go, D or C goes. Right, so see some of these conditions. So we are required to write a program to print all the groupings in which the family members can go to the party. So I'll just go to my Visual Studio Code where I have written it. Um, and then later on I'll provide link to the GitHub uh, where the actual code is. So first of all, what I'm doing is I'm taking the family members as ABCD. This is taken as a string and I'm generating all the combinations. So remember, this is not the permutations, this is combinations. So if we see here, so this is the code to generate combinations. So let me just put a breakpoint here. Or rather, let me put a breakpoint here and then run the code. So in uh, order to generate the combinations, what I'm doing is I am just taking one character at a time, uh, placing it on the output string, and then erasing the last character from the string. That is uh, using this recursive approach. I'm first traversing through all the characters. Then when this recursive function calls itself, and when uh, I reach the last character, then this recursive function call comes back, and then I just call the arrays here. So if I see here, this generate combination has printed out all the combinations. That is, so again, there is a formula for uh, the combinations. Mm, okay, let me just go through the combinations formula as well. So the formula for combination says something like this, that NCR is equal to n factorial divided by r factorial multiplied by n minus r factorial. So combination of n things taken r at a time. So initially what we are doing here is there are four things. We are taking one at a time, then we are taking two at a time. So let me just show how the combinations are calculated here. So we have four things A, B, C, D. I'm taking 4C1, something as this. So it will be 4 factorial uh, divided by 1 factorial multiplied by 3 factorial. So it becomes 4. So it will be out of four things taken one at a time. So it will be A, B, C, and D. This is the combination. Then 4C2, it will be 4 factorial divided by 2 factorial multiplied by 2 factorial. So it will become 4 into 3, uh, 4 into 3 divided by 2 factorial. So 2 factorial will cancel out, so it will become 6. So what the combinations will be, take out of 4 taken 2 at a time, so it will be AB, BC, CD, and then or maybe what we can do is we can just fix A and then fix B and something like this, AB, AC, AD, and then we'll fix B. So it will be B, AB is already taken, BC is not taken, and then BD, and then fixing C. So CD, is it taken? No, CD is not taken. So it is CD and There is no other combination. So six combinations, and then 4C3 out of four things taken three at a time. So it will be 4 factorial divided by 1 factorial into 3 factorial, same. So it will be 4. So fixing A, B, and C taken two at a time, then fixing A, B again, and D, and then fixing B, C, B, C, and D, and then um, third, and what will be the fourth? A, B, C, A, B, D, fixing B, C. So it will become A, B, C, B, C, D, and B, C, D, and then fixing C, D. So it will be A, C, D. So this is the four combinations, and then taken four at a time is equal to 4 factorial by 4 factorial. So it will always be 1. So it is A, B, C, D. So how many combinations we have? Four here, 4, 6, 10, and 14, and 1, 15. So 15 combinations. So let's count them. A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, right. So 15 combinations are generated through this code. Then what I have done is for printing the combinations, let me just uh, comment this out and let me just do this. So then I have passed this vector which contains all the combinations into the print grouping function. So now this print grouping function, let me just go through it here until it loads. So now this print grouping function does what is, um, okay, it reaches here. So in this print grouping function, this vector input will contain all the combinations. That is, it will have all 15 combinations. So I'm just iterating through all the combinations. I'm just checking the conditions. I have taken the Boolean variable. If I find A, then I'm setting Boolean of A as true. Otherwise, if I find B, I'm making BF as true, else false, CF and DF as true. So as per the first condition, A does not go with D. That is, if A and D both are present, I'll not do anything. A and C goes, B will not go. So if A and C are present and B is also present, so it's not a valid condition. If A does A does not go, D or C goes. So if A is not going, um, if A, okay, so this D is already checked, this C is here. And then there is one condition that B will always go with C. It means that if B is present and C is not present, then we need to skip it as well. Otherwise, we need to print the condition. So these are the combinations, that is A, C, and D. So B will always go with C, so BC, and otherwise these. So let us just once cross check against the conditions which we had and the output. So it says A does not go with D, so AD is not there. B will go with C, BC is there. If A and C goes, B will not go. So if AC is there, so AC is not there, uh, B will not be there, okay. If A does not go, D or C goes. So D and C is there and A is not there. So I think these are the correct conditions. So, and about the time and space complexity of this algorithm. So in order to generate this combination, we'll have somewhere around uh, 15, 4 to 5 recursive function calls. Those stacks will be created. Space, so that will be the space complexity of this function. Time complexity would be when we jump to another stack. We will just do uh, again we'll iterate through it, then we'll again iterate through it. So the time complexity for the recursive function call becomes n raised to power 2 raised to power n. So it becomes somewhere around, it's 4, so it becomes uh, 2 raised to power 4, it's somewhere around 16 times. And let me also check this, the time complexity. And for this one, it's straight. The space complexity for this is there is no space complexity because we are just traversing through the input vector, and the time complexity is O(n) because we are just going through each element, each combination rather. So number of combinations which will be generated. So this is how the code goes like, and thanks a lot. Have a good day. Bye bye.